Hello students, myself Dr. Deepak Verma. In this video, I will explain Swedish circle method for stability analysis of slopes. This method is applicable for cohesive frictional soil, so the required shear parameters are C and phi. In this method, the total slip surface area is divided into number of vertical slices, so this method is also called method of slices. This method was developed in Sweden, so it is known as Swedish circle method. For stability analysis, consider this figure. The total slip surface area is divided into 5 number of slices. For analysis, consider the slice number 3. The forces acting on this slice are: first is W, weight of the slide acting vertically downward. We can determine the value of W if we know the dimension of the slice, that is width and average height, and also the unit weight of soil. The weight line is resolved in two components, that is N and T, where N is normal and T is tangential component, and alpha, it is the slip surface angle. The second force is the cohesive force acting along the slip surface. Third, the reaction R acting at an angle of phi with the normal. Also, there are reaction on the sides of the slice, that is R1 and R2, which are assumed to be equal. So, the first force is weight W acting vertically downward, cohesive force C acting along slip surface, reaction R acting at an angle phi, reaction R1 and R2 at the sides, which are assumed to be equal, and so it may be ignored. If the length of elementary arc is delta L, then cohesive force becomes C dash delta L, where C dash is unit cohesion, and the reaction R. These two are the resisting force. Further, T equal to W sin alpha, it is the sliding force. As shown in this figure, it is the tangential component T, that is W sin alpha, it is a sliding force, reaction R plus cohesive force, these are resisting force. For determining the factor of safety, we take the moment about O. The sliding moment equal to sliding force multiply R, where R is perpendicular distance of tangential component from O. Second, resisting moment is equal to C dash delta L into R plus R into small r sin phi, where C dash delta L, it is the cohesive force and the perpendicular distance is R. Second is the reaction R, it is reaction R, and perpendicular distance from O, it is R sin phi. We can determine the value of R sin phi if we know the value of R and phi. From this triangle OEF, it is a perpendicular distance, so its value in terms of R, it becomes R sin phi. Further, by resolving the forces in radial direction, as shown in this figure, it is the normal component, it is a tangential component, and it is R. So if we make a force triangle, it is normal component, it is tangential component, and it is reaction R at an angle of phi with the normal. So we can determine the value of N and T in terms of R. The value of T is R sin phi and value of N R cos phi. So the value of R in terms of N, it becomes N by cos phi. By putting the value of R in equation number 2, it becomes N tangent phi into R. So the equation 2, it is C dash delta L into R, it is same as here, plus n tangent phi, that is it is sin phi by cos phi multiplied by n, and r is same here. So we can determine the factor of safety by dividing resisting moment by sliding moment. So resisting moment c dash delta L plus n tangent phi, and the sliding moment that is t into r, and r is common, so it is cancel out. For whole area of the slip surface, the factor of safety becomes summation of c dash delta L plus summation n tangent phi divided by summation t. If the length of slip surface is L, then factor of safety is c dash delta c dash L plus summation n tangent phi divided by summation t, where n is w cos alpha, t w sin alpha. The design step of this method: first, assume the slip surface and divide into suitable number of slices, and preferably of equal length. Then determine the weight of slices, that is W. Third, resolve the weight into normal and tangential component. As shown in this figure, it is the normal component and it is tangential component, and alpha, it is the slip surface angle. So the value of n, W cos alpha, value of t, W sin alpha. Then determine factor of safety using the expression that is c dash L plus summation of n tangent phi divided by summation t. Thank you.